Bright Tuty. Every student matters.
Hello students, in this lecture we will be starting with the first topic of the fourth chapter. The name of this chapter is materials, metals and non-metals. Right, so we have to study about two kinds of materials in this lecture, which are metals and non-metals. Students, you must have heard a lot many times about metals in your daily life, right, such as iron. We use many articles made up of iron. Then copper, we use copper wire, we use gold jewelry, we use silver jewelry, we use utensils made up of aluminium, right? So there are many metals that you have heard of, right? Similarly, there are certain non-metals such as carbon, which is extensively being used as a fuel as well, right? So there are many metals and non-metals that come across you in your daily lives. So in this lecture, first of all, we will be discussing that how can we differentiate between a metal and a non-metal, right? So the first topic is physical properties of metals and non-metals. So students, basically for differentiating, there are two kinds of properties that we discuss. The first one is physical properties. Second one is chemical properties, which we will be studying in the next lecture. Right, so the first properties which we are discussing right now are physical properties. Physical as such, appearance and hardness, and certain properties which can be, which do not require any chemical reaction. Basically, they do not have any chemical changes in them when we talk about physical properties, right? Chemical properties involve the chemical reactions which metals and non-metals create, right? So, first of all, there is a table in front of you. Here we have a list of object/material. Then their appearance. There are two kinds of appearances, shiny and dull. Shiny and dull. And then third one is hardness, regarding if any substance is very hard or it is not very hard, or if it is soft, right? So let us start with the first example, that is iron, right? Now, iron does not have a shiny appearance, right? Comparatively, according to non-metals, it is still shiny. So, we will write it as shiny, because if we polish iron, it will come out as shiny. Then it is very hard. It is used for making trains, bridges, buses, cars. So, it is very hard in nature. Then coming to coal. Coal is basically a fuel, right? It is a fossil fuel. It has a very dull appearance, right? It is a powdery substance, and it does not have a shiny appearance, and it is very soft. You can crush it with the help of your hand, so it is soft. Then coming to sulfur. Sulfur again is a dull substance and is soft. It is not hard again. Then coming to aluminium and copper. If you notice, both these are shiny, and both of them are very hard, right? So if you look into this table properly, you will be able to understand that the substances which are shiny and hard, for example iron, aluminium and copper, these three are metals, and the two which are not shiny and hard, both of them are non-metals, which are coal and sulfur, right? So what did we learn from this table? That the substances which are shiny in appearance and are very hard, they are basically metals. And if they are dull in appearance and are soft, then they are known as non-metals. So basically metals have two properties which we have just seen, that they are shiny and hard, while non-metals are dull and soft. Right? Now students, blacksmith beats an iron piece. Basically blacksmith in Hindi is known as luhar, right? So a blacksmith beats an iron piece or an article made up of iron, like a spade, a shovel or an axe, right? Basically any iron piece can be beaten and converted into something else. Would you expect similar change if we try to beat a piece of coal? Basically, when you beat up a piece of iron, it changes its shape. It can be converted into sheets, right? But if you try to break coal and try to change its shape, it will not happen. What will happen basically? The coal piece will immediately shatter and break into pieces. It will not remain intact because its nature is brittle. While metals such as iron are not brittle, they are malleable. We will be studying about this property, what is malleability and what is ductility, right? So basically, iron piece does not break into pieces, does not become a powder because it is malleable. It changes its shape on beating. While coal, being a non-metal, it is very brittle and suddenly breaks, right? So understanding from that example, we will be discussing the properties which are malleability and ductility. These both are the properties of metals basically. This is not seen in non-metals, right? So first of all, look at this activity that is in front of you. You have to take a small iron nail. As you can see in this picture, this is a small iron nail, a coal piece, right? And a piece of thick aluminium wire. You have to take three things: a small iron nail, then a piece of thick aluminium wire. Imagine this to be the thick aluminium wire, and then a piece of coal, right? And a pencil lead as well, right? This is the pencil lead. Imagine it is very thin, right? This is the pencil lead. This is the piece of coal, and this is the aluminium wire. Alright, so now what happens? Beat the iron nail with a hammer. You have to beat the iron nail with the hammer, right? You have put the nail, you are beating it with the help of the hammer, right? But take care that you do not hurt yourself. Take care because hammer can hurt you as well if you do not handle it carefully. So try to hit very hard, right? Basically what happens, you try to beat the aluminium wire also, then repeat the similar experiment with coal and lead. The observation that you will make is that the iron nail flattens. It flattens, right? As it has this part, the top part, it flattens. The iron nail completely flattens and aluminium wire also flattens. They both kind of convert themselves into sheets, right? While when you try to beat lead, pencil lead and the coal, they both instantly break. They get converted into a powder because of the beating. So this is what the property is about. That the property of metals by which they can be beaten into thin sheets is called malleability. The property due to which this iron nail was getting converted into a sheet, it was getting flattened, is because of this property which is malleability. Alright. This is a characteristic property of metals. Remember that this is the property of metals. Then another property, the property of metal by which it can be drawn into wires is called as ductility. So there are two kinds of properties. First one, in which the metal can be converted into sheets, that is malleability. The second one, due to which the metal can be drawn into wires. We have seen copper wire, aluminium wire, magnesium ribbons. This is only because of the property that is ductility. And they both are only seen in the case of metals and not in non-metals, right? They are the characteristic properties of metals only. Now when you hold a hot metallic pan which is without a plastic or a wooden handle, you get hurt. Basically imagine this to be the pan, right? Imagine two pans. Now there is a pan with a plastic handle on it, and you are heating it continuously, right? You are heating it continuously, and you are heating this pan, second pan as well, continuously, and this one has a metallic handle only. Basically, the material which is present here is also present here. It does not have a plastic handle. So if you heat the pan for like half an hour, you will notice that if you touch this metallic handle now, this will be very hot. This will be hot. But if you touch this plastic handle after half an hour, it will still be cold. Cold as in it will not become hot. It will remain at a normal temperature, at the room temperature. It will not become hot, right? So what happened here? When the whole pan was metallic, the heat traveled from this stove to the container to its handle as well. That is why you were able to feel the heat at the handle, because the heat traveled from the bottom of the container, from the bottom of the pan to the handle of the pan as well. While in the first case, the heat traveled into the metallic pan as just like the second case, but it could not heat up the plastic handle. So what did we learn here? That metals conduct heat, right? While non-metals, as plastic is a non-metal, it does not conduct heat. It does not conduct heat. It remains normal when heat reaches it, right? So this was one property. Then when an electrician uses a screwdriver with a different kind of handle, what happens? There is a screwdriver, right? You have seen screwdrivers. This is the screwdriver, basically used by electricians. Now what? Basically what is happening here? So this screwdriver has a metallic end and a non-metallic handle. Non-metallic handle. Why is that so? Because whenever this screwdriver is inserted in a plug, this is the electricity plug. When you insert this screwdriver in a plug, the metal conducts electricity, but the handle does not conduct electricity because it is non-metallic. So what does this tell us? That metallic substances or metals conduct electricity while non-metals do not conduct electricity, right? So let us move on to the next page. Now conduction of electricity, discussing it in detail. Now recall how to make an electric circuit to test whether electricity can pass through an object or not, right? You made an electric circuit to see if the substance conducts electricity or it does not conduct electricity, right? So this is the activity. This is a cell. This is a bulb. These are wires, connecting wires to complete the circuit. And this is an iron nail, right? This is the first experiment of this table. You have to check for various materials if they are conducting electricity or not. So the first case you took was the iron nail. So you connected the wires, the ends of the wires to the iron nail. Now you have to see if it conducts electricity. Now when the circuit is completed and iron nail is present here, as iron nail is made up of a metal, the current flows through the cell, through the nail, to the bulb, and then to the cell again, and the bulb glows. So this tells us that iron rod or an iron nail is a good conductor of electricity, right? This is the information that we obtain, that iron nail is a good conductor. Second example is, instead of this iron nail, We are taking sulfur, right? Imagine this to be sulfur now. This is sulfur. Now sulfur is a non-metal. The electric current comes up to this end, but it is not passed on because sulfur does not conduct electricity. So the bulb does not glow. So it is a poor conductor, right? Third case is you have taken a coal piece in the circuit. You have revolved the wire. You have connected the wires to a coal piece now. So if this is a coal piece now, then again it is a non-metal. It will not conduct electricity. So it is a poor conductor again. While the fourth case is when you take a copper wire. Now imagine this to be a copper wire. So as copper wire is conducting in nature, the current will pass through the copper wire to the bulb and the bulb will glow. So copper wire is a good conductor. So this tells us that non-metals are poor conductors while metals are good conductors, right? Because they let the electricity pass through them. So metals are basically conductors of electricity, right? Now coming to the next property, metals are sonorous. Sonorous basically means that they produce sound. What is this sound? The things made of metals produce a ringing sound when struck hard. So basically look at this picture. There is a pan and there is a wooden stick with the help of which this boy is trying to hit the container. So when he strikes the rod on the container, a ringing sound is produced. A ringing sound is produced. So this is the property of metals only. Suppose you have two boxes similar in appearance, one made of wood and other made of metal. Suppose you have two boxes. Which box is made of metal by striking both the boxes? If you strike the boxes, both of them, the sound made will be by the metal container, the metal box, because metals have this property of being sonorous. Now in this case, if you had taken a wooden pan, imagine it to be a wooden pan, right? Wooden, not just pan, any instrument. And if you try to hit it with a wooden rod, it will not produce any sound. This is because non-metals, because wood is a non-metal, non-metals do not produce any sound. They are not sonorous, right? So this was another property to differentiate between metals and non-metals, right? So coming to the inference now, what is the inference? Metals are hard, lustrous, malleable, ductile, sonorous and good conductors of heat and electricity. This is the inference. These are all the properties listed down in this single line. That metals are hard, lustrous means shiny, malleable that can be converted into sheets, ductile that can be converted into wires, sonorous that they produce sound, good conductors of heat and electricity that we have already seen. The examples of metals are iron, copper, aluminium, calcium, magnesium, etc. Right? These are the examples. Now sodium and potassium are soft and can be cut with a knife. These are exceptions. Sodium and potassium are metals according to their chemical properties, which you will be studying about in the next lecture. They are metals according to the chemical properties, but according to some physical properties such as hardness and luster, they are not, they basically are exceptions as compared to other metals, because they are not shiny and they can be cut with a knife because they are very soft. Another exception is mercury, which is found in liquid state at room temperature. All other metals are solids and they have high melting and boiling points, but mercury has a very low range of melting and boiling points, so it exists as a liquid at room temperature. So this is also an exception. But when we talk about the metals generally, these are the properties which are common mostly. These are the properties These are the common examples: iron, copper, aluminium, calcium, magnesium. But sodium, potassium and mercury are somewhat exceptions in some of the properties. Now what non-metals? Non-metals are soft and dull in appearance and they are brittle. What does brittle mean? That they break. They suddenly break when you try to hit them. They break down into a powdery mass on tapping with a hammer. Basically, this is brittleness. They are not sonorous and are poor conductors of heat and electricity. Right? So, the examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. And basically, all the gases are non-metals. Right? Now, there is another exception in the non-metals, that is graphite. Graphite is a non-metal, that is an allotrope of carbon, but it is the best conductor of electricity. That is because of its structure that you will be studying in higher classes. You do not have to remember this. I am just telling you for extra knowledge that graphite is an allotrope of carbon, which is the best conductor of electricity. So these were the properties of metals and non-metals, the physical properties.